So let's do another example. Y equals negative 2x squared plus 2x plus 12. Okay. Again, we're going to try to find the vertex first. So we can find the x value of the vertex by taking negative b over 2a. So this will be negative 2 over 2 times negative 2. So negative 2 over negative 4, or 1/2. So that's the x value of our vertex. We can find the y value of the vertex by just plugging this back into the equation. So y equals negative 2 times 1/2 squared plus 2 times 1/2 plus 12. So this will be negative 2 times 1/4 plus 1 plus 12. Negative 2 times 1/4 is negative 1/2. So negative 1/2 plus 13 will be positive 12.5. So let's graph that here. So the axis, the vertex will be here at the point 1/2 12.5. So we'll put it right here. Okay, so that's our vertex. And then we know our axis of symmetry will be the line x equals 1/2. So we got a vertex at 1/2, 12.5. And then the axis of symmetry will be the line x equals 1/2. Let's put this equation back up here just so we remember. Plus 2x plus 12. So now finding the intercepts, we know there's definitely a y-intercept because there's always a y-intercept. Okay, so this will be whenever x is equal to 0. So this will be y equals negative 2 times 0 squared plus 2 times 0 plus 12. So this will happen at y equals 12, or specifically it will happen at the point 0, 12. So there's our y-intercept. Now we have to ask ourselves, is there an x-intercept, or are there any x-intercepts? Well, we know the vertex is here, and we know this graph opens downward because the leading coefficient is a negative number. So a negative a means it opens down. It opens down like this. That means we're going to have two x-intercepts because it has to hit the x-axis twice. So let's find these. So we'll set y equal to 0. We'll try to solve this equation. 0 is equal to negative 2x squared plus 2x plus 12. Now if you use some of your factoring techniques or some of our other techniques we worked at, you end up getting that x equals negative 2 and x equals 3. So just to save us a little time there, you should be able to use other things from this lecture to figure those numbers out. So there should be an x-intercept here at negative 2. So negative 2 is 0, and then an x-intercept here at 3, 0. And then the other thing we can get is, since we know the axis of symmetry is right here, that means there's an equivalent point here. From 0, 12, there's also a point here at 1, 12. So I guess there's a fifth point, and we can sketch this parabola relatively easily. So let's try one more. Okay, so y equals x squared plus 4x plus 7. Again, we'll go after the vertex first. So the x value of the vertex is always just negative b over 2a. So this would be negative 4 over 2 times 1, or negative 4 over 2, which is negative 2. And then I can find the y value by just plugging this back in. So y is equal to negative 2 squared plus 4 times negative 2 plus 7. So this will be 4 plus negative 8 plus 7. So it will be a positive 3. So negative 2, positive 3 is what we should get for our vertex here. We'll go ahead and graph this. So negative 2, 3 will be right here. Okay, so that means our axis of symmetry will just be the vertical line that runs through the vertex. So we'll just make a notation of this. The vertex is at negative 2, 3, and so the axis of symmetry will be at the point x equals, or the line x equals negative 2. So y-intercepts, there's always a y-intercept. So we can find the y-intercept by setting x equal to 0 and solving for y. So we'll do y equals 0 squared plus 4 times 0 plus 7. And we'll end up getting an intercept at y equals 7. So we can go ahead and put that on here. So let's see, I need a little more room. 5, 6, 7. So we're right here at the top of our graph. I don't want to go off of the screen. So we'll have a point right there, okay, at 0, 7. And of course, I know there's another point on the other side of the axis of symmetry, so we'll get to that in just a second. But I do have to ask myself, are there any x-intercepts? Well, we start here at negative 2, 3, and we know it opens upward because this is a positive a value, plus we already see that there's a point up here. So this is actually going to open up like this. It'll never actually hit the x-axis, so in fact there's not an x-intercept for this one. So there's 0, so we can say there's no x-intercepts. So we don't have to worry about finding them. And if you did try to find them, you would just run into a lot of problems. You wouldn't be able to solve the quadratic equation. You would end up taking some square roots of negative numbers. So even if you skip this step and you try to solve it, you could still figure out that there aren't any x-intercepts. It's just a little easier when you know that ahead of time and don't try to find them. So let's see. We know that there should be at least one more point here. This is at 0, 7, so we should have another equivalent point over here at negative 4, 7 as well. Remember, this is a symmetrical graph, so we should be able to just fold the points on top of each other from side to side and get the other point that we're looking for. Okay, so let's try one more. So how about y equals x squared minus 2x minus 8. So this is the other one from the notes. Again, we'll go after the vertex first. Okay, so the x value of the vertex is negative b over 2a. In this case, it'll be negative 2, so a positive 2, over 2 times a, so 2 times 1. So this will be 2 over 2, or 1. And then I can find the y value by plugging this into the equation. Y equals 1 squared minus 2 times 1 minus 8. So 1 minus 2 minus 8 is negative 9. So we should have a point here, 1, negative 9, that's our vertex. And then the axis of symmetry will run directly through that vertex. All right, and by the way, the axis of symmetry is the line, of course, x equals 1. That's how we name that line, since it's a vertical line. Y-intercept, we'll do this by setting x equal to 0. So we'll get y is equal to 0 squared minus 2 times 0 minus 8. So there is a y-intercept at negative 8, or the point 0 -8. That means there's an equivalent point over here at 2, -8, because of the axis of symmetry. It tells us there's a symmetrical point on the other side. Also, there are x-intercepts for this one because we know it opens upwards since the leading coefficient is positive, so it has to have 2 x-intercepts. So this will happen when y is equal to 0, so that 0 is equal to x squared minus 2x minus 8. This one factors nicely into x minus 4 times x plus 2. So we end up getting that x equals 4 and x equals -2. So 1, 2, 3, 4. Here's one of our x-intercepts, and then 1, 2. Here's our other x-intercept. We can draw a pretty good sketch of this graph.